sprayers are a real time saver when it comes to pesticide applications for large fields. The ability to set down precise amounts of chemical or organic product to large areas at a time can be essential to a successful agricultural business. The key to effective spraying of any kind is the efficiency of a properly calibrated and prepared sprayer unit. Consequently, a poorly calibrated or equipped unit can prove unsafe and be very costly. Let's take a few minutes and review the steps for proper setup and calibration of a boom sprayer. The first step is about safety. Always consult pesticide and manufacturer's labels for requirements on PPE or personal protective equipment. Depending on products used in the sprayer in the past, it may be necessary to wear gloves, safety glasses, or boots when performing a calibration. Having a good knowledge of your sprayer's history will be valuable. Keeping accurate application records or other notes related to operating your sprayer are essential to a safe application year after year. When preparing to spray product on a field or crop, be sure to review all mixing and loading instructions on the pesticide label for required PPE. Please note this may differ from application-required PPE. For the purposes of this video, the demonstration sprayer has been cleaned, flushed, and filled with water. But because of previous pesticide usage, all participants are wearing gloves for exposure protection. Next, let's consider variables related to boom sprayers, such as nozzle size or type, and tractor speed. Nozzle sizes and types come in different varieties and for multiple purposes. Make sure that the size and type of nozzle that will be used for product application is the one being used during the calibration process in order to maintain that consistency during spraying. If the nozzle attached has been previously used, make sure that it is properly cleaned and unclogged in order to allow correct product flow. When cleaning the nozzle, use compressed or canned air rather than blowing through the nozzle to reduce unnecessary pesticide exposure risk. If the nozzle needs further cleaning, use recommended brushes and cleaners. Just simply poking a wire through the nozzle could result in damage that permits too much product flow, wasting chemicals and perhaps damaging crops or inflating pesticide costs. If a nozzle is damaged or worn to the point of ineffectiveness, it's best to replace it with a new nozzle of the correct size and type. Tractor speed can be challenging, but one way to ensure consistent applications is by maintaining written records of previous applications, making notes of positive and negative results. Once a winning strategy is achieved, good record keeping ensures that future employees and generations can enjoy continued success. While GPS and other rate control technologies can make the process easier, it's still essential to calibrate based on the average speed over the course of the distance for accuracy. Proper distance between nozzles and the height above target are determined by recommendations provided by the nozzle manufacturer. Refer to the sprayer's owner's manual before calibration and take careful measurements to ensure accurate and effective calibration. For this demonstration, the boom consists of a width of 20 inches between nozzles and a boom height of 20 inches above target. Now that we know that the boom sprayer is properly equipped, let's look at the calibration process using the 1/128th method. This method offers a very basic and easy to calculate way of measuring gallons per acre usage in an agricultural setting. First, mark out a plot of ground measuring 204 feet long for a single pass of the tractor. As you can see on this chart, that is the correct calibration travel distance for nozzles set at this spacing. This will replicate the 1/128th of an acre for calculation purposes. Using a stopwatch, measure the time it takes to make a singular run from the designated start point to the finish. Then make a return pass and record the time again. If the time differs by no more than 2 seconds, average those 2 times. Repeat the process if the time differs by 3 or more seconds. During this run, the tractor, RPMs, and pump pressure should be operated at the same settings as the proposed application. In our demonstration, the time measured was 27 seconds. Now, with the tractor parked and the engine and pump running at the same settings, spray water through the boom. Do the spray patterns from all of the nozzles appear uniform? If not, remove the tips of suspect nozzles to check for excessive wear or blockages. Once all the nozzles are spraying correctly, and for that same amount of measured time, 27 seconds, collect the liquid from each nozzle into a measuring cup designed for pesticide use. Using the same pump pressure and engine speed to be used during the spray, the same as was used during the calibration run. If any of the spray tips vary by more than 10% from the average collected, those tips will likely need to be replaced. After you have collected a consistent average amount from all of the nozzles, add the amount of total spray collected and divide that total by the number of nozzles being sprayed. This will provide you with the average amount of product being applied from each nozzle. The average amount of ounces sprayed translates to the amount being applied in gallons to each acre. For example, if you collect an average of 18 ounces in the measured time, that means you are spraying 18 gallons per acre from the sprayer. Ideally, you'll want to repeat this process a total of at least 3 times in order to determine an average and more accurate measurement. And that's essentially the quick and easy 1/128th method of calibrating a boom sprayer. Of course, this is just one of many methods you can use. The most important fact is to use and operate a calibrated sprayer whenever you make an application. As we mentioned previously, properly calibrated sprayer equipment is essential to achieving efficient and cost-effective pesticide applications. And in so doing, you can be assured of better crop yields and a tighter control over chemical costs for a superior bottom line. Thanks for watching. For further information about this or other calibration information, head to the website on your screen.